Yo, hit it with a high and a low.
Yo, what's up guys? So we've got the, this picks up pretty quickly actually. I usually play a track at the start of the live stream just whilst it picks up, whilst people start to join. That track is a beautiful, beautiful piece of music called, it's by Minnesota, and it's called High Low, all one word, H-I-L-O-W, High Low, and it is the Charles I remix, so Charles I is all one word as well. Actually, let me just, let me show you that on the screen here. Beautiful, beautiful piece of music. Really nice, deep, lovely sub bass. Really nice piece of music. It popped up in my SoundCloud, and so I hit that like button. So, we're looking at the JL Audio XD1000/1 V2. Lovely amplifier, lovely board design. Not quite as good as their old Slash series, I don't think, but it's a very, very compact 1000-watt amplifier. Okay. So, in our last, now H1 Nicholas is in the room, is in the place. How's it going, buddy? We've got all these other guys as well. Thank you very much for tuning in. First of all, before I get cracking with this, I wanted to ask Nicholas a question. If that's possible, my friend, if I could ask you a quick question regarding, because you know a shit ton about these amplifiers. So, I have a really, really strange scenario. With an amplifier that I've been working on, okay? So, when you turn the amplifier on, the Class D switching malarkey is supposed to enable straight away. Okay, it doesn't. In order to get the Class D crap to jump into life, you have to feed the amplifier with some RCA signal, like a sine wave through the RCAs, which I've seen before. I've seen that before, and it's been like a broken veer somewhere, etc. This one is different, okay? If I put my stupid fucking OBS just keeps dropping out, so apologies if it cuts out for you guys there. So if I put my fingers and I touch my fingers on the high side drive, yeah? So if I put my fingers and touch the high side drive, suddenly the drive looks kind of okay. As soon as I remove my fingers from the high side drive, the drive looks bad, and it fails to build. So what the fuck is going on there? it's almost like by touching the high side drive, it's like grounding a little bit extra through me, which is helpful for it. I don't know what's my body doing to the high side drive that would then allow it to build properly and not look like crap. Really, really strange. But that's something for another day. Hi Jesse, what's up on this lovely Friday night? Just going from work and we'll enjoy the next 2 days off. Yeah, it's Friday! It's Friday, guys! Friday night and we're looking at a JL Audio. Fantastic stuff. Ah, yes. Good stuff, good stuff. Now, this JL Audio which we looked at before, we replaced the power supply section in this JL Audio already. So the power supply section is over here. We have a whole row of IRF 3205s. So these are all replaced very nicely. We have replaced the gate resistors and we also replaced the driver transistors. So there's a little block here of 4 driver transistors and these smoked up really bad. These got really stanky and smoky. So we replaced the NPN and PNP driver transistors. We replaced the 3205s along here and the power supply works beautifully. Now, this amplifier also had a dead output section, and the output section is over here. So this is the output section, and we have two banks of FETs here. I think we have one high and one low per driver. Okay, the driver you can see there is missing. There's a driver pad there that the driver's missing from. The drivers were shot in both of these, and also so were a bunch of resistors. So in my previous live stream I removed obviously the 4 output FETs. I've removed the 2 driver ICs which are off the board, and I removed some of the resistors that also got killed. I have replaced a couple of the resistors here, which is a 10 ohm basically being used as a fuse, which is on the VCC of the driver chip, with the VCC being the chip's power rail. So I replaced the 10 ohm basically a fuse resistor. So in this live stream we are going to replace the 2 driver ICs, the remaining resistors and the output FETs, and fingers crossed this thing will jump into life and not be an absolute headache like the amplifier that I've been working on that I was asking Nicholas about. The OBS dropped out, so I don't know if actually the question came through okay, but yeah, absolute headaches. And you can see here I've got this long ass thing here. RS Components sent me 2 chips in this great big long stick. So the chips are stuck to the tape on each end. So there's literally 2 tiny IC chips that were sent in this great big long stick. Really weird. I'm waiting for Vanessa to jump back on the stream as well, because I was helping her with a Orion amplifier that she was struggling with. I want to see how she got on. How was work for you today, Jesse? Was it stressful as the last few days have been, or was it a little bit better today? Hopefully it was a bit better, because it's a Friday. No one likes a stressful day at work on a Friday. I'm having a stressful day at work on a Friday, and I am not happy as a result, but jumping on this live stream is cheering me up. Get a bit of company. A bit of company in the workshop always cheers me up. Okay, so we're going to start off by replacing these 2 resistors here, which are 4R7. They're marked up with 4R7, which means 4 ohms, 0.7. When you see the R on a resistor, on a SMD resistor here, if you see the R letter means basically point. It's like the decimal point. Oh, this is overexposed as crap, but so you're not going to be able to see that. But the R is the decimal point. So if you see an SMD resistor that's labeled up as 22R, that's 22 ohms, 22.0, 22 ohms. If you see 4R7, that means it's 4.7. I'm curious at what time it is there. It is 10 past 1 in the morning. 1 AM basically. Somebody recommend me some good music with bass that's not crap. You mean rap? So do you mean that the rap is crap, or you mean the rap is what you want? a little better as I change a few things up to release some stress. Wicked. Always good to change some stuff. Stress is not what you want. Stress actually causes aging, so the stress is not what you want at all. Like some decaf stuff, yo. I'm not able to help you with that because I don't really listen to sort of decaf style stuff. I listen to kind of deep dubby stuff and drum and bass stuff. Okay. So we're going to replace these resistors first of all. 4R7, here you are. Now this 4R7 is next to a diode. And they will be working together, I imagine. I think the 4R7 and I think that's a Zener diode, I think they work sort of together. We are not in shot, we are doing this one. That's one 4R7 in place, and our second 4R7 is just over here. Hot air is blowing this away. Now you see, I hate putting SMD resistors in upside down. Like technically there's nothing wrong with putting an SMD resistor in upside down. You just can't read the number on it. It kills with my OCD. I don't like it. It has to be the right way around, you know. Okay, there we go. So that's the resistor on. Now we need to put the driver ICs on, and this is the last bit of surface mount soldering we need to do. So driver chips are going to go on, and we have to get the orientation correct. So the on the board you can see here the marking has a little where are we? The marking here has a little notch on one of the sides, and that notch indicates that you can line it up with the chip. So the chip will have a little dot on next to pin 1. So you want to line the notch up with dots on the chip, and that is the correct orientation. Okay, that's one driver IC, soldered down nicely, almost looks factory. The next one is over here. So once we've done these two, once we put these two on, I'm going to power the board up, and we're going to check that there is a good drive wave on each of the output pads before I put the output FETs on. Do you like fixing amps, or do you do it as a hobby? I do it for a living, my friend. This is my main source of income. I also distribute car audio brands, digital designs, and a few other bits and pieces. And yeah, so this is my main source of income. This is my job. That's what I do. But you got to get some flux soon to help you with the surface mount components. Yeah, I do. I've ordered some nice flux and I'm waiting for it to come because the flux which I currently have seems to go conductive when it gets hot. It's a fucking nightmare. I've had loads of issues, and people who have been watching my streams will have seen those issues in the flesh, where we have a bunch of flux on the board, not even that much, and across quite a big like gap of pads, and there's a resistance there, and then when we clean it up with alcohol, suddenly the resistance goes away. It's really, really strange, and I've only ever had that issue since I've started using this flux. So this flux actually has 2 stickers on it. It has a sticker underneath the sticker. Oh, it's in a different language. Okay, that's fine. So I'm just, I don't know. I'm wondering whether this flux actually is something different, because there's another sticker under the sticker. But yeah, not good. It's meant to be a no clean flux. Because it's a bit safer than using flux you need to clean. Okay, cool. So now, oh, there's one resistor missing here. There's one resistor missing there. So let's have a look. What resistor is that meant to be? We are missing a 20 ohm resistor. We're missing a 20 ohm resistor, which is meant to go here. That's annoying. Because I ordered all the resistors together from RS Components, and I should have got all the stuff together. Okay, now let's see. I need to see whether we've got a spare 20 ohm resistor anywhere on the donor board now, if that's the case. So 20 ohms is a bit of a weird one. I could temporarily series up a couple of what I might do just to get this working on stream, because that's really annoying. I think I'm missing some stuff from RS Components that I ordered, because I ordered a whole bunch of other things from RS and they haven't arrived yet, and only half of the stuff I ordered has arrived. So what I'm going to do is, just to get this up and running on the stream for you guys, I'm going to series together 2 10 ohm resistors. Because that will work exactly the same, no difference whatsoever. So let's series up 2 10 ohm resistors just for the stream, because I don't think I've got another 20 ohm. 20 is a strange resistance, and I get a lot of those. Looking for my 10 ohm resistors. You should get a magnifying glass. I do have a magnifying glass. There's a magnifying glass here, but my eyesight is still good enough that I can see pretty much everything. All the SMD components I can see pretty well without needing that. There we go. Here's some 10R resistors. 10R0. So let's series 2 of these together so that I can show you this thing working. So to series these together on the board, what I'm going to do is I'm going to put them at right angles on the pads. I see a JBL behind you. Yes, you do. You see a JBL 1004 4-channel amplifier. Yeah. Okay. So I'm going to put one resistor like that. Then I'm going to put the other resistor next to it, like this. Oops, if the air doesn't blow it away. Okay, see that? So I've now got 2 10 ohm resistors, both at right angles there. I think this is a little bit overexposed. Oops. Come on, focus for me, baby. Focus for me, baby. Is it me, or does that look a little bit overexposed? Let me know how that looks, because I'm only looking at it on a tiny little screen. So we've got 2 resistors at right angles to one another, like so. So to make them in series, I just need to connect them together. Very simple. So I just need to run a little bit of solder across the edge here, and they will be seriesed, and that gives me 20 ohms. I do have a fine tip soldering tip somewhere, but it's not connected and I can't be bothered. This will work just fine for this. There we go. Going to try and clean up the connection a little bit so it's a bit nicer. Whoa, that's a big blob. Don't want it quite that big. Yeah, this is where the flux would come in handy, but I don't trust the flux that I've got. The flux that I've got really sucks. It's like conductive, so I don't want to use the flux that I've got. Oh come on, I had it a minute ago. Come on. Right, that'll do. That'll do just for a quick test to show you guys this thing working, and then I'll order a 20 ohm resistor before I give it back to the customer. But yeah, let's get a little bit of alcohol to clean up this board a little bit. From our soldering and whatnot. Okay, so if I measure between those resistors that I've seriesed up, we should see 20 ohms. So the one over here, my test lead resistance is probably too high. That one's reading 22. Oh no, this is my test lead resistance. So yeah, we've got 20 ohms on that one. Oh, my thing is out of view. Skip up. So we're reading 20 ohms on this one, and our new one that we've just seriesed together with two 10 ohms is reading 20 ohms. There we go. So let's power her up now and let's see whether we have some drive waves on the outputs, and that's very important because we need to check that this thing is going to send the correct waves to the FETs, because if it doesn't, then they can blow very, very quickly, even with a small power supply. What's everybody's plans for their Friday night then, other than watching me? Other than watching this this questionable board repair? Okay, so let's give this baby some power and I will show you what the drive waves should look like on these gel audio amplifiers on the outputs. if you're ever repairing one of these yourself, this will be useful because you can see what the drive waves should look like, because I think this should be alright. Beverage. Going through all my ICs and other parts and organising, so many thermal labels are blank. Yeah, I know that feeling. Okay, cool. So let's power up and let's have a look at them waves. Just forgot to put that back on. Okay, so we have some power supply waves there. The output rails. Let's have a look what the output rails look like. Okay, so we have our positive output rail. I think this amplifier runs on only a positive rail. From memory. Just going to make sure that before we add crazy power, there's no shorts between the pads on the drivers here. No, looking good. Okay, so let's put some power. There we go, so power supply is up and running. And let's see, what do we have on the pads for the outputs? So, we don't have anything at the moment, no drive waves whatsoever. And that's likely because without any FETs on there, these amplifiers need to be driven with some signal from an RCA input in order to show you their nice waves on the pads there. So we're going to have a look which one is our our input. Which one's our input here on this board? So inputs is on the right here. So plug our RCAs into the inputs from our signal generator. Like so. And now let's see if we have the waves that we require now that the thing is being fed with 45 Hertz. Interesting. So we don't seem to have anything either, even when we feed the thing with some signal. That's interesting. That's not usually the case. Let's make sure that these chips are getting their VCC. So we've got 9 volts worth of VCC. Okay. It's possible that these amplifiers are do actually require their... hang on a minute, we do have some kind of wave here. It's just very, very low amplitude. Yes. Okay, so I think this thing does need... Yeah, you can see there we do have some kind of wave going on here. I think the thing needs the actual FETs to be in for this thing to actually go off properly. So the waves are looking, the squares are looking sharp. That's the main thing. Okay. Okie dokie. So I'm happy with that. We have some sharp looking waves. So what I'm going to do is now fit the output FETs in place and power her up once more. And see if it works. So with these JL amplifiers, it seems that you can't really effectively check the drive waves with the FETs out of the circuit. It doesn't seem, unless there is still a fault that we are yet to see. The drive waves look good on the pads of the ICs. Yeah. So when I on my last video, I checked the drive waves to the pads of these ICs, which looked great. So we're going to open up these FETs. And before we drop them in, we want to make sure that the rail capacitors on the amplifier have sunken down. Because if we drop the FETs on while there's still power on the board, then that can blow things. So we should have 0 volts everywhere on the board. Yes, we do. 0 volts everywhere on the board. Just making sure that RS Components sent me all the same batch, which they did. Sometimes they don't. Sometimes they send you a mismatch of batches, which is not helpful in the least. I'm just going to check the specifications of these on our transistor tester. Looking good. RDS is nice and low. RDS is nice and low. It's a Friday night. I should really be having a drink. Once we've if this JLOD amplifiers works, I will go and grab a drink. I think. Because it's Friday, and who should be without a drink on a Friday? RDS should always be under 1 ohm. My transistor tester has test lead resistance, so you can't go by the RDS that the transistor tester tells you. You know, you can't take that as completely accurate. But I've been using that tester for long enough that I know when it's reading something that's nice and low and when it's reading something that's not so low. So that just read 0.2 ohms, which is very low for that tester to read. The actual RDS of those FETs will be far lower than that, I imagine. But yeah, the tester obviously has some test lead resistance involved, etc, etc, so it never gets it quite right. But it's consistent with its tests, so you can use it to find bad FETs. Okay, let's cut these legs off. No, don't cut my legs off! And fingers crossed, if we give this thing some power, we should see some nice looking drive waves on these FETs. We're going to wait for them to cool down a little bit. We shouldn't need our signal generator anymore. Is H1 Nicholas watching at this point by any chance? Are you still there, buddy? I saw him at the start, but I haven't seen him since. Whoop that trick. Okay. So, we're just going to wait for these to cool down a little bit. And once they have cooled down, we're going to apply some power, and then fingers crossed, the thing works. And hopefully the thing don't go scrap, bop, bop. Because that wouldn't be very nice if it went scrap. Because these FETs, although I've only got 4 of them, they actually are quite expensive. 69, ooh, 69 watching. Okay. So what do you reckon, guys? Do you reckon that just changing the ICs, the burnt resistors, and the FETs will solve this? Cool, let's apply some power then, see what's going on. .53 volts on the FETs, but no switching. Huh. Okay, no switching. I wonder why there's no switching. Let's feed it with a little bit of RCA voltage. Feed it with a little bit of RCA signal. It could also be partly to do with we're only running 9 volts into this. So we'll try 12 volts again in a minute. But usually these things work. Okay. I'm just going to wiggle the inductors just to see if the inductors are screwing out or not. Okay. So we're not sure then why this thing isn't giving us our Class D switch wave. It's a JL audio though, so it could be clever, and it could be not switching until it receives some RCA signal. So let's apply some RCA signal, see if that helps at all. Okay, no, so RCA signal does not help this thing come on. Interesting. We have nothing at the outputs. Okay, so there's still issues with this that we need to find then. There's still issues with this we need to find. So it's not just as simple as replacing the driver ICs. That's a pain in the butt. I thought this was going to be a nice simple one. And wait for our rail voltage to climb back down. Those Monster 10-inch subs, I've no idea, because the person who bought them off me, the customer, he ended up in prison. So I've no idea where the subs ended up. No idea where they are at this point in time. Okay, let's, first of all, next thing to do to try is to try our 12 volt power supply and see if the amp needs a little bit more voltage on the inputs to come on. But I highly doubt it. I think we've got more issues here than what we bargained for. In prison for what? The guy got put in prison for crash for cash fraud. So he was deliberately causing car road traffic accidents, albeit minor ones, in order to claim horrific amounts of money on insurance and compensation. Him and a group of other people, and they scammed little old ladies out of hundreds and thousands of pounds on their insurance. Well, their insurance companies. They scammed their insurance companies out of hundreds of thousands of pounds and caused road traffic accidents on purpose to benefit themselves financially. And that's probably how he bought my subs. Indeed it is. That's probably how he bought all of his car audio. I'm not collecting my new power supply. I'm having it shipped. I'm having it posted, so it should be in the post pretty soon. Yeah, it should be arriving pretty soon. Okay, so 12 volts, does that make a difference? So if I have my adjustable supply, I don't have to keep doing this bullshit of changing this all around all the time. Okay, a 12 volt power supply then. We'll probably see the same rail voltage. We had 50 volts before. Oh, we have 69 volts now. But once again, no switching. Okay, so the input voltage being 12 volts is not the issue. God damn it! God damn it! So in order to work out why this thing isn't coming on then, we need to have a look at the data sheets. I think we should probably start by looking at the data sheets for these driver ICs and work out what they're not getting or what they don't like. I'm going to take my multimeter to the board just for a moment. I'm going to check some of these Zener diodes and whatnot. So the fact that we've got no switch means that it's not happy about something. $963 on that Zener diode. $963 there. Now the strange thing with this is that we did have a good drive wave before we put the driver ICs on, and that's very strange. So that means it's not the before drive circuit. That's not the issue here. There's a couple of components on the bottom of the board here I'm going to have a look at, because on the bottom of the board by here there is a couple of 4R7 resistors. I'm going to make sure they're alright. Capacitors there. We have a couple of Zener diodes as well on the bottom, so we're just going to check that they're not shorted. Check they're reading roughly the right thing on here. Should say about 450. Yeah, they all seem pretty much okay. These small capacitors aren't shorted out either. I'm going to try attaching a load to the outputs to see whether these amplifiers need a load to start their switching. They might do. Is the live stream down? I don't know, guys. Can you hear me all right? So now we've got a load attached. I'm going to try plugging it in again and see if that sorts the issue. Sometimes these amplifiers, they need a load on the outputs for the Class D to have a complete feedback loop. So let's see. Okay, so still no switching. Okay, so it doesn't need a load. The load is not the answer to this. So we're going to look up the data sheets of these driver ICs to see, make sure that they're getting all the correct supply voltages at their pins. Because if they're not getting their correct supply voltages, then the drive ICs won't be switching on, and they won't be able to do what they need to do. They won't be able to do their thing. So let's look up the data sheets for these. And these are the IR. I think they're the 2.1. Let's have a look. IRS 2101S. Okay, so look up the data sheet for this. Sorry, 2101S. That's what I want. So let's have a look then. Okay, so pin 1 is VCC. So let's make sure that we have VCC at pin 1. Let's power the board up. I'm going to add my scope to this screen. Video capture device, scope. There we go, that'll do. So I'm going to see whether we have VCC at pin 1, which is important because the chip needs that in order to turn on. So we have 9 volts worth of VCC on both chips. Cool. So pin 2 is high input. That's the high side switch input. So we have 8.9 volts on that one, and we have 9 volts on the other one. So we've got 9 volts on both the high side switch pretty much. Although it's jumping around a little bit on this second IC. It's jumping around a little bit now. So it doesn't want to come on now. Interesting. So now the thing doesn't want to come on. So why doesn't it want to come on now? Okay, so it seems to have shorted out some of these FETs. Great. Great success. Not. It shorted the replacement FETs, yes it did. Very, very annoying. Very annoying. That means I've got to order more. I can put some intermediary FETs in here for the time being to get it up and working. I can put some similar FETs from my inventory of FETs, but I will need to put the originals in it before I give it back to the customer. So I need to order some more originals. Very annoying. No, these are not 3205s. These are some weird JL Audio output FETs that I don't see any other amp using. I'll tell you what they are in a sec. So these are IRFB 4410Z, and they're not cheap either. So I think that just cost me about 5 or 6 quid, which is fine. It's fine, it's part of repair. It's part of the jam. I usually do buy more when I order for spares, but these ones they didn't work out any cheaper by buying them in multiples of any greater value, and these are FETs that nothing else uses other than this JL. So I didn't really think it was necessary, and I was quite confident that the repair was going to be okay, but obviously not. Alright, so let's troubleshoot this then with the FETs out, because obviously they're dead. So we know that there should be drive waves on these pads with the FETs out. We know that's the case now. So let's put some power back into the board. So that issue cost me around £6 or $10. Those blowing, maybe around $10 or less. Okay, so chip VCC in, present, 9 volts. Next one, high switch input is sitting at 9 volts, so it rides along 9 volts. Next one, low switch input is sitting at 1.5 volts. Next one along, common is ground. Ground is 1.8 volts. That's strange. Why is ground 1.8 volts? Could be that these chips aren't grounded then. It could be the ground path got damaged. Interesting. I'll check that in a moment. We've also got 1.8 volts on the speaker terminals, speaker output grounds here. Very interesting. Okay. 1.8 volts on the ground for these ICs. Okay, low output is going to be nothing because we haven't got any low output. That's the next pin along. VS is doing something. VS is doing some kind of janky wave. What does VS stand for on this chip? VS stands for high side floating supply return. Interesting. HO is high output. Okay, and the next one along is VB. VB is high side floating supply. So we've got some kind of waves going on. The ground is also... it's very, very strange. Okay. I'm actually going to remove both of these ICs because before I fitted these ICs, we actually had good looking waves across the whole board. So I'm going to remove these ICs and just double check that they are still there, and maybe we can troubleshoot it with the ICs out. The ICs are brand new, yeah. Pretty much everything on this output section is brand new, yeah. I'm wondering if the chip isn't being grounded properly. We had like 1.5 volts on common, which is a bit strange. Does it still measure 1.8 volts with the DVM with scope disconnected? Good question. That is a good question from a username that is a bunch of letters and numbers. I shall check that. But we're going to remove these ICs just for now. Great video, it says whoop that trick. Cheers buddy, it would be even a greater video if this thing actually worked. Hopefully we'll get to the bottom of what the issue is on this stream, so you guys can know what the issue is. If you ever come round to wanting to repair something like this. Okay, so the driver ICs are out. So before, we had nice looking waves on here with the without the ICs in. So let's power her back up. Go. So let's see what we have. So I'm going to go back to the data sheet here. VCC we know is present. High side input. Let's see, what do we have at high side input? So we have 10 volts on high side input. Low side input we have nothing at high side low side input now. Ground is now at 2.5 volts on the scope, but we said to check with the digital multimeter. So I wonder where I should put my ground. I reckon we should maybe put our ground on the digital multimeter somewhere like the RCA rings, because that's usually the output ground. So let's see, what does it measure on the digital multimeter? 2.4, yes, so there is 2.4 on the common pin of this chip. That might be correct. JL are a bloody headache and they do things weirdly, so that might be okay, but we really don't know until we start checking around some other bits and pieces on here. Let's get back in there. I'm looking to see if we have any drive waves with the ICs out. So pin number 4 is common, pin number 5 is low output. Aha! Okay, so as you can see here, we do have a nice looking drive wave on the low output here. Nice looking healthy 3 volts. It's a 3.4 volt RMS square wave. Okay, so the VS, what's VS? VS is probably like what does VS stand for again in this one? High side floating supply return. Okay, and the next one along is the high output. The high out. Oops. This pre-board keeps bloody popping out because it's leaning against the desk. That's very annoying. Get in there. This riser board just keeps popping out the board. Come on, go back in there. Stupid thing. God damn it. Oh, for fuck's sake. Alright, there we go. I almost need something underneath here to lift it up. Right, let's see, what have I got to lift it up? Some tester tape. Need to lift it up off the bench a little bit so it doesn't keep popping itself out. There we go, that's better, right. So, VS, yes, we have some square waves. Low side output. So we haven't got anything on the low side output. I don't know if that's an issue or not. I wonder if that's an issue. Sorry, high output. Sorry, high output we don't have anything. It's the high output that we don't have anything on. So I wonder if that's an issue. I wonder if high output there should be something. Alright, let's have a look at the circuit for this. Where's the common connection? Here we go. So VS should be to the... It says it should be to the load. So VS should be to the ground of the load, by the looks of it, perhaps. Common should be connected to VCC with a capacitor. I wonder if the capacitor on between VCC and ground is leaking. That might be C34 on the board over here. That could be one of these capacitors, these yellow things. So you see here, I wonder if that capacitor is this capacitor on this kind of schematic, which is a suggested typical connection for this. There's also a capacitor between VS and VB, and VS and VB were, what was VS and VB? High side floating return, high side floating supply. I think they're fine because I think we have square waves on both of those. This is where it would be very useful to have a working example. So sometimes when you're stuck with a repair, if you don't have, I mean, schematics can only tell you so much. They can't tell you what the waves are supposed to look like. So sometimes having a working example that you can compare the drive waves to is very, very useful, because I could then know what pins the drive waves are supposed to be present on, because I have not worked on these amplifiers before. So the only way that you learn what the waves are supposed to look like and where they're supposed to be is by repairing something and then looking at it and checking it what everything should be once it's working. But if you've never probed a working one, or you've never actually fixed one before, then you don't know what's meant to be there and what's not meant to be there. Let's have a quick look through the live chat. Because I haven't looked through the live chat much yet. Nasty ass snowstorm with 100km/h winds. Holy crap, that's not good. Have you ever watched iPad Have you ever watched iPad Rehab? Jess shows great ways to make bridges and connections like you just did when you have to improvise. I've watched a little bit of her channel, but not a great amount. But I really like her content, so when I get some spare time and I haven't got to do this shit, I'll probably sit down and watch some of her stuff. Found the issue with missing minus 15 volts. Snapped trace at the step down converter. 15 volt is back, but more issues. Probable OP amp related. Ah, shame. What's the issues, Father Steph? What issues are you having? Fortunately, I have to work all weekend. No fun. Ah, that sucks. If a computer GPU has a connector for a fan, can I connect a fan to it? Maybe check that there's voltage there first, but I don't see why not. I can pick up a Lanzar OptiDrive amp for cheap. Anyone familiar with them? I heard they're the last good ones that Lanzar brought out or something. They still make the Opti stuff. Just when you get it, open it up and just make sure that none of the inductors or the transformers are wobbly, or there's no loose leads on the inductors or the transformers. If there is, then take some CA glue or some epoxy or something and just glue the crap out of them. Make sure they don't move around or vibrate when they're mounted to a box. Check that all the MOSFETs and transistors are clamped to the heatsink tightly and none of them are off center. The Pride subs are fantastic. Def Bonsai I'm not a huge fan of, but they do quite well. Are remanufactured amps worth buying if you can get it at a slightly lower cost? So like refurbished, I don't see why not, as long as it comes with a warranty. It usually means that it's been repaired or it's a customer return that had a fault from factory that they've rectified. Good quality audio products seem to last as long as you treat them right. Yeah, I agree. Sony and Vega aren't bad at all. Yeah, Sony and Vega have done some lovely stuff. Okay, let's get back to this board repair then. So, I'm a bit confused about the small voltage on the com pin. I'm a bit confused about the small voltage on the com pin. I'm trying to think logically about what will have died when this amplifier went down. So, when this amplifier went down, okay, we had shorted FETs on the output section. Okay, we had blown driver ICs, and the VCC fuse to those was blown as well, which is not good. So they were put under stress. So let's have a quick look at the circuit again for this. What else would have been put under stress when this thing blew? So if these FETs shorted out, so we've got connections from there, etc. Now, will any of these capacitors have been put under strain or anything? So we've got a capacitor between VS, so this is VCC. So if VCC fuse blew, there would have been current drawn from VCC, which means that there might have been current drawn through this diode here, which is on VCC, between VCC and VB. There might have been current, or there would have been a low resistance there. So what's that? Where's that diode then? Where's that diode? So that is a diode that's connected to VCC on one side, and the other side is connected to VB. And VB is pin 8. Okay. So VCC is here, and pin 8 is here. So put my multimeter back on diode beep setting. So we want to find diode that is connected. Ooh. I've got 15 ohms between VCC and this diode. Interesting. Where's the... I don't see a 15 ohm resistor anywhere on the board. The other side should be connected to 8, pin 8. So I'm looking for a diode that has a connection on pin 8 of the IC. It's not that one though. Doesn't seem to be that one. What about this one? Well, that's just the gate resistor. That's not connected to VCC either side. It's possible that JL Audio have done things differently with this, rather than the typical connection that it suggests. So I'm a little bit confused at why we have 15 ohms between our VCC and this capacitor. Sorry, this diode here. Where's a 15 ohm resistor on the board? There doesn't seem to be a 15 ohm resistor on the board anywhere. 22 on the gate. We should have 249 ohms up here. I'm going to check these two big capacitors. I wonder if there's anything wrong with these two big capacitors. Let's flip the board over and let's just check these two big capacitors. Where's my camera? There we go. So let's check those big capacitors. No, that one's okay. That one's okay. It's charging. Okay. Huh. So, across these small capacitors here, I seem to have a short circuit. There's some very small... No, this camera is way overexposed. Let me just turn that exposure down a little bit here. That's a little bit better. That looks a bit nicer. So there's, you see this capacitor here? There's a direct short circuit across this capacitor and this capacitor, which should not be there. I don't think that should be there, because a short circuit across a capacitor doesn't make any sense. So let's remove those capacitors just quickly and see whether the short circuit goes away, or whether it's somewhere else on the board. Yo Nicholas, what's up, buddy? Yeah, we put so this is the JL Audio. If you not sure if you remember it last night, we've got an IR. What have we got? The driver. What's the fucking driver? It's a 2101, I think. Yeah, IR2101 driver. I was looking at the schematic for this. So, yeah, we have, when I apply power with everything connected, we have absolutely nothing, zero drive anywhere. So it's actually very similar to the BAMF. Plagued by no drive. Diode between pin 1 and pin 8 should be there, yeah. Yeah, it should be there. It might be one of these ones that's on the bottom of the board, actually. Because we've got some components on the bottom of the board here as well. But I found this short circuit across this capacitor. I don't think that should be there. It doesn't make any sense. Why would there be a short circuit across a capacitor? So. Bev is low in distorted output. Jumped the preamp board and got more output. Clean switches knobs. Only OP amps left to check. Ah, strange. I think this one's going to be a bit of a bitch to take off because I think there's quite a lot of thermal mass here, so I might need to just preheat the board a little bit around it. Now the only problem that I'm going to have here is if these capacitors, that cap should be in parallel with the output drive resistor to speed switch on time. Okay, cheers buddy. I shall check that. I don't think it should be shorted though. The only problem we're going to have is if this is shorted, I don't know what value it is, because I don't have a schematic for this amplifier, so that's going to be a little bit annoying. I do know somebody with a schematic for this amplifier though, or if we, why don't you get a heated tweezer? I do have a heated tweezer soldering iron actually, I do. I usually find that it takes a bit longer than the hot air station, but sometimes the hot air station takes a while. Where are my tweezers? Yeah, I can see my heated tweezers. I do have some of those. But I find that they also take a little while, especially with these sorts of pads that have a high thermal mass. It just takes ages. So I'm just going to use my iron here, just to get it off the board with my. Look at that! Even holding my iron directly on both the pads, it still doesn't want to come off. So I think my tweezers would struggle with that quite a bit. Okay. So let's see if our short circuit is still there with these capacitors off the board. Right, so we still have a short circuit on the board with the capacitors off, so it's probably not the caps then. I'm going to put those caps back because I don't know what value they are, so I don't want to lose them. Screw it. I'm going to clean off the pads first. Clean off the pads first. Apply some new solder to there. There we go. Finally heated the area enough for the for that to work. I do plan to design my own amplifiers at some point in my future. It's a long way off yet though. I've only been doing this for 1 year, so it's a long way off yet before I can even think about designing my own amps. Designing your own amps and repairing them is a completely different kettle of fish. But I would love it one day to have my own brand of amplifiers. So I just have to keep learning, keep expanding my knowledge, and maybe one day we'll get there. Okay, so not the caps. So Nicholas said that these should be in parallel with the output resistors. So there's actually about 1 point something. There's a very small resistance across these. Imagine if we cool it down, that will drop. So there's a very small resistance across those. Is there a short still across any of these? Let's have a look. Okay, no. So we are hunting for the diode, which is in between. Because I want to check that one, because that one might have been affected by whatever caused the amplifier to go down. In between VCC and VB. We still haven't necessarily found that yet. We're looking for VCC and VB. Now VCC is does that look a lot better? That looks a fair bit better without that high gain thing, or my camera turned on, I think. So VCC is over here. So we're looking for a, now we've got between this one and this one here, this diode over here, we've got a 15 ohms, which is curious because there's no 15 ohm resistor on the board, which is what I was looking for earlier. I was trying to find out, so where's the 15 ohm resistor on the board that's making that connection there? So I'm finding that very curious. Now, what else is this? What else is this connected to? What else is this diode connected to? Anything else it's connected to around here? Anything else it's connected to around here? Or is it just connected to VCC? See, it's not connected to VB. VB is this pin of the output. It's not connected to VB, so it's not that. Doesn't seem to be connected to anything else. I wonder if it's connected to anything on the bottom of the board. So I have to put my probe on up here, on the top, and try and work out if it's connected to anything on the bottom. Doesn't seem to be connected to anything on the bottom of the board either. Ah, so what the fuck? I do have some solder wick. Here, but it sucks. I haven't got around to grips with it yet. I probably need some solder flux, but my solder flux turns conductive when you heat it, so that sucks. I'm waiting for some new solder flux. Okay, it's also connected to that 4R7. Ah, okay. I think I found where our 15 ohms are. Our 15 ohms is. So our 15 ohms on that diode is actually we're reading two resistors. So the 15 ohms on between VCC and this here, we're reading between the 4R7, which is directly next to it, and we're also reading a 10 ohm resistor somewhere. Yes, that's where it is. So we're reading before the fuse for the IC chip and the 4R7. So there's a 4R7 that's then connected to this diode. So should this diode be connected to VB? It's not at the moment. According to this, according to the spec sheet, we should have a diode between VCC and VB. And I wonder if that's why we haven't got any drive, because the diode would pass some DC voltage. So we should have, yes, look at that. So VCC is 9 volts. So we should have 9 volts on VB. We should have 9 volts on VB through a diode, and I don't think we do. Kind of a blown trace on the PCB. Okay, that's going to be really annoying because these traces, you can't really see them because it's all black. I'm going to try and have a look. I'm going to try and get my magnifying glass here, and I'm going to try and follow the trace of VB to see where the trace actually goes. So if I move that over to here, I'm going to follow this trace of VB here. So I'm going to follow the trace with my multimeter probe. The trace for VB goes here. Ah, this is looking too dark now. See, this is annoying. This is looking too dark now. What can we do to sort that out? Auto gain control, I guess that is. That looks a bit better. Could be time to bodge a jumper wire. Yeah, perhaps. The traces are usually very good on these amps though, so I'm going to follow the trace here. The trace goes along here. It goes to this 20 ohm resistor. Okay, it goes to this 20 ohm resistor here. So it goes la da 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 da, goes to this. It also goes to this 20 ohm resistor here. And then out of the back of this 20 ohm resistor, it then goes to the gate. So it looks like it's using that as to drive the gate through two 20 ohm resistors, or through a 20 ohm resistor here. And there's a Zener diode here as well, which will be to do with the gate drive. So it looks like that this one, pin 8, is actually it's using to drive the gates with, or driving the, I think it's driving the high side. So this diagram suggests that, you see, this diagram, it's connected differently. It's connected differently. See, look, this LO should be the drive. I haven't got this the wrong way around or anything, have I? I've got it mixed up. Thanks for taking the time to give away all the knowledge. I may learn something useful from all this. Thank you very much for the kind donation, Love86. And I know that you have donated a few times before, so massively appreciated. Thank you so much. NOK is Norwegian kroner. So pin 1 is on the dot. So pin 8 is above the dot. So we've definitely got that the right way round. So why is it using that to drive the gate rather than low output? Man, this is the point where electronics school really would have helped. This is the point where going to like some sort of electronics classes or something would have helped out. Right, I'm going to start a kind of more... I'm going to start removing things from the board and testing them on my transistor tester. Kind of a blind approach now. So the things that I want to check on this board that I am skeptical about, that could be causing issues here, is this capacitor, these diodes. Resistors we can check on the board, they all seem to be okay. High side drive is done on pin 7 and pin 6. Pin 7 and pin 6 don't seem to be connected to the gates. Pin 8 is definitely connected to the gate through two 20 ohm resistors, or through a 20 ohm resistor. Fish. Ah, of course. With all my heart, buddy. Yeah. Fish Buddy, love you with all my heart. All my heart. Thank you very much for the kind donation, my friend. Okay, so let's check these resistors, these capacitors first of all in our transistor tester. So the first one measures about 10,000 nanofarads with an ESR of 0.37 ohms. This one is measuring the exact same, so these caps are probably good. So the next thing I guess we want to check is these diodes here. The caps I'm removing here are marked with, what does that say, 106 and then 324. So I'll have to work out which one of those I'd need to Google search. Nicholas says pin 6 should go to the source of the MOSFET and pin 7 should connect via a driver to the gate. Let's see. Let's see whether they do, because that's not what I saw when I probed things earlier, but so pin 6 should go to the source, Nicholas is saying. Source of the MOSFET. Let's see. Nope. Pin 6 is not going to the source. Well, this is, yeah. Well, it's sort of, okay, so sorry, pin 6 is going to the source of one of the MOSFET pads. It's going through a 250 ohm resistor, which I imagine is one of the ones over here somewhere, maybe? Where are we? There should be some 250 ohm resistors somewhere. Yes. There's a 250 ohm resistor over here. And that is going to the source. So yes, it does go to the source. Pin 7 should be going to, should connect to via a driver resistor to the gate. Let's see. No, it doesn't connect to the gate. What connects to the gate is number 8. Pin 8 connects to the gate of one pad. And pin 3 connects to the gate of the other pad. So it's being driven by 8 and 3. Eight and 3 are high and low on the gates. Nicholas says that's totally wrong. Yeah, man, I don't know. Speak to JL Audio. They do things fucking weird. I can get a schematic for this amplifier. So Nicholas, if it interests you in any shape or form, if you wanted to see what the fuck they're doing, I can get you a schematic for this amplifier. I probably couldn't get it right now though, because the guy who I get the schematics from for these is probably going to be asleep. Yeah, that's what I'm thinking. It doesn't match up, does it? But this thing was using IR 2101s. This was using IR2101s. I should have a little bag here. Did I put the original parts in this bag? I can't remember. Yeah, because the guy who I speak to about these, he's the certified UK repair technician for JL Audio. He has all the schematics and all that jazz, and he actually said yes, the RS2101. So this is definitely the right chip for the board. It's definitely the right chip for the board. Hello HDVidsRO, thank you for joining us on the stream. We have some headaches as usual. Headaches on a Friday. Did you fix the power acoustics? Pretty much. Still something a bit weird going on with it. I can make it work, but I'm not happy with how it works. You have to get the power acoustic to work, you have to drive some RCA signal into the amplifier to get the Class D switch to work. And I don't think it's happy. It's not happy about something. It almost works. A little bit of tweaking with it, and it will be fine. So let's measure these diodes I just took off the board here. Okay. That's reading it correctly as a diode. 576. That's reading exactly the same. So these diodes are both reading identical values, which probably means they're fine. Let's just do a quick diode check on here. So we should have nothing one way round, and we should have value the other way round. So we've got 242 that way round. We should have nothing one way round, and 242 the other way round. So these diodes are both fine. These diodes are both fine. I used to rebase songs, yeah, I used to. Pin 4 ground on the IC, and 1 on the source, pin 3 of the FETs should be connected. I shall check. But I believe that JL Audio are using these chips in an unconventional manner, because it doesn't seem to match up with what we have here, does it? Very strange. So let's put these diodes back, because they are okay. They're all okay. Now, can anybody remember which orientation these capacitors were supposed to go? Because, stupidly, I didn't note the orientation before I took them off the board, so I can just check back through my live stream. Could they have installed the IC flip side up? So if it was backwards... No, I'll tell you why not, Nicholas. I'll tell you why not. Because pin 1 should be VCC, which it is. Pin 1 is VCC on the board, and pin 1 is VCC on the datasheet. And we have two resistors which act as fuses for VCC, which are 10 ohms, and they are... Yeah, correct, yeah. So it couldn't be backwards. Because if it was backwards, it would be sending... What would it be sending? It would be sending VCC to pin 5. It would be sending 9 volts to pin 5. And pin 5 is the low output. Caps had a reddish line mark to plus mark on the board. Oh yes, there's a plus mark on the board. I completely forgot about that. Isn't the line on the capacitors though sometimes ground? So perhaps they were like this. Plus side towards the output of the FETs. Is the line plus side? I can't remember. Did I fix the BAMF? Almost. We're almost there with it. I can get it to work, but I'm not happy with how I have to get it to work. Something strange going on with this. Just cleaning up some of these solder connections, because some of them are a bit messy now. So, not any closer to finding out what the fuck's going on. Yeah, it's usually not this much of a headache. I always get the headache ones that I choose to stream. Whenever I choose to stream, I always get the headache ones. That wasn't there before. That doesn't look right. That looks, that does not look right. So, I think we seem to be going backwards. We seem to be going backwards with this. So we don't have any drive waves. Oh no, yes we do. Apologies, yes we do. No, that's fine, okay. I thought we were going backwards with this, but it's fine, we're not. Can anybody remember? I'm pretty sure that we had 3 pins with drive waves on them before. I'm pretty sure that we had 3 pins with drive waves on them before. We've only got 2 pins with drive waves on them now. I'm pretty sure that we had a drive wave on this one, which we do. A drive wave on this one, which we do. And I'm pretty sure we had a drive wave on this one. H1 Nicholas says the IC is flipped. I really don't think it is, buddy. If the IC was flipped, then we'd have to have VCC over this side here. If the IC was flipped, we'd have to have VCC over here, right? And this is a square wave. So why would we have a square wave on VCC? This is where VCC is, pin 1, which is 9 volts DC. And this is the VCC, this is the VCC fuse. So it's definitely not flipped. Unless the markings on this chip are wrong, unless the markings on this chip are flipped. So that should be, the dot is there, that should be pin 1, like so. That should be VCC. Show me the pins, you have signals. I will show you the pins where I have signals, buddy. I'll go through every pin and you can see on the scope here what's going on. So, pin 1, we have 9.4 volts. Pin 2, we have 10.8 volts. Pin 3, we have nothing. Pin 4, we have 2.5 volts, which is common, which is really strange. Pin 5, we have a drive wave. Pin 6, we have a drive wave. Pin 7, we have nothing. And pin 8, we have nothing. If I inject 40 hertz, if I inject 40 hertz into this amplifier, into the RCAs, you can see there that we have. Can I get that to stand still, perhaps? Stand still, damn it. Doesn't want to stand still. So yeah, if I inject 45 Hz into this board, we can see that it's actually giving us the 40 Hz square waves instead. Does it do anything else on any of the other pins? Nope. I'm going to try putting the ICs back in place and going from there, seeing what the junk's going on. Old School Carl Audio, thank you very much for the kind comments, the kind words. I enjoy these videos too when they go well, or when the repair isn't an absolute ball ache like this one is. What is on pin 8? Sorry, on pin 8 is nothing. Pin 8 is nada. Nothing at all. The resistor values on pin 8. What do you mean, buddy? So what does pin 8 read to ground? Pin 8 is connected to the gate of one of the MOSFETs. And it's connected through a 20 ohm resistor. So I've put the ICs back on. I'm going to power her up and we're going to see whether we get anything going on. Any sort of drive. We'll see. Let's see what that changes. What does it change? I'm just going to change this resistor because I think it's gone slightly out of tolerance. Probably when the FETs died. This is one of the this is one of the fuse resistors. Whoa! Need to be careful with my tweezers because that is a capacitor. Small slip of the hand. The resistors connected to pin 8 between the pin 8 and the gate are 20 ohms. Looks like both of the these resistors died again. IC pin 4 and low side output FET source pin 3 should be connected to each other. IC pin 4 and the source should be connected to each other. There seems to be a capacitor between them or something. They're not directly... no, hang on a minute. Ah yes, they are connected, sorry. They're connected to one of the pads. Yeah, one of the pads is connected, yeah. One of the source pads is, one of the source pins is connected to one of the, to the low side, yeah. Low side is connected, that's correct. So there's some issue, yeah. There's some issue here. So when we put the driver in place, okay, the waves no longer look any good. So you see this? When we put the driver in, this is now what the waves look like. The waves look horrific. I wonder if something got damaged further down the line. Away from the drivers. So if we look further down the line, because the original drivers were damaged pretty bad. So if we go further down the line, what's sending the drive to these drivers here? So if we go along a little bit, you can see what's next. What's sending the drive to these drivers? It looks like we might have some driver transistors here in the middle of the board. So let's zoom in here. So so you see there's some SOT23 drivers in here, and they seem to be sending the waves to the driver ICs. So I wonder if they got damaged, because the driver ICs were very badly damaged. So, but you see, if these things were damaged, I wouldn't have thought we'd get clean square waves with the driver ICs out. So let's turn the board and let's just see what we have on these. So we have bad looking waves on the outputs of these. What do we have on the inputs of these? Looks like we also have bad looking waves. No, look, see, we have a relatively good looking wave on the input of one of these. It's not great, but it's kind of okay. But then on the output, it looks bad. So I wonder if these small transistors became damaged. I wonder if these small transistors became damaged. So I guess the only thing I can do next is perhaps try to replace these small driver transistors. Because that's the next thing in the chain that might have got damaged. It's very strange. As soon as we apply the drivers, it's almost like it puts a load on those transistors. Well, what I'm going to do is I'm going to snap a mental image of the location of these drivers, what orientation they're in. So we've got Z, ZA, ZA, going from left to right. Okay, ZA, ZA. So if I remember from before, we correctly replaced those over here in the power supply section. Those are the same ones that we replaced over here. And we replaced those with, what did we replace those with? It was 2X and 2T, I think it was. I think it was 2X and 2T that we replaced those with. Yes, it was 2T and 2X. Okay. So the ZC was the 2X. So let's try changing those then. Thank you very much for the donation. Again, Fish. Cheers. Thank you, buddy. Do you watch any EV blog? Great resource for you if you're planning on educating yourself further. I don't personally, but maybe I should. So we're looking for 2 T's to replace those with. What have we got in here? Some 2 T's. go, a couple of 2Ts here. Hi Foxby TV, how's it going? Thanks for joining in the stream. Where do you get all these amp boards compared to the larger amps you repair? What do you mean, buddy? Where do I get them? Where do I get them from? So let's see, has changing those small driver transistors here, ZC and ZA, does that make any difference to the drive waves on the drive ICs? I really hope it does. I really hope it does. If it doesn't, I'm not too sure where else to turn to be perfectly honest with you. Everything that I repair is generally sent to me by a customer for repair. Ah, sigh. Sigh and bugger. So that hasn't helped out at all, in the least. If anything, it looks a little bit worse. I was like, oh. So these transistors are not the issue. Right, but we do know something. We do know something. What we do know is that something is affecting the drive waves coming from these middle driver transistors. Something is causing the wave to go bad when the IC is in place. So when we put the IC in place, those waves go bad. So something seems to be affecting, pulling those waves down, or doing something bad to those drive waves when the IC is put in place. But what though? But what? Dear me. It's getting late. It's almost 3:30 in the morning. I might call this one a night. I might call this one a day and go and get some hard-earned rest. This one's not going too well at the moment. So why would the drive waves go bad the second that we put that in? I'm gonna just put those original drivers back in because they're obviously not the problem. So because they're not the problem, they're better than the ones that I just fitted. So I'm just gonna swap those back out very quickly to the originals. That IC does not match up. Yeah, I know, but that is the IC for this board. That is what it came with. So I don't understand. Very confused. What I'll do is I'll call it a night for this evening. We'll get some sleep. I shall obtain the schematic for this amplifier tomorrow. I'll obtain the schematic, and once I've obtained the schematic, we can see what those chips are meant to be and exactly how JL Audio has incorporated them into their amplifier circuit. Because it doesn't. I mean, Nicholas is right. Nicholas is absolutely right. These chips, like how they are on this board, doesn't seem right at all. And what they're connected to does not seem right at all. But that's what came off the board, so that's what we've got to work with. That was nice and quick. Those four replaced again. Just going to power her up one last time. Nah, nothing. The ground pin matches up and the VCC matches up. But the rest of it doesn't. The wave seems to be changing in shape, getting better or worse. It looked a bit better than that a minute ago, I'm sure it did. The thing is, right, is that this amplifier was never repaired before. It came into the workshop with IR, and came into the workshop with these 10, whatever the chips are that I've got on here. It came in with these chips. IRS 2101. It came in with those chips from the factory. So it's not a different version. It's not that I've got the wrong chips from somewhere. I've ordered those chips because that's what it came with on the board. So very confused. Very confused. Ah, hang on a minute. No, wait a second. What's going on here? What's going on here? What's this transistor on the board that has a short circuit pretty much between 1 and 3? What's this transistor on the board that has a short circuit between 1 and 3, and why does it have a short circuit between 1 and 3? There's also another small IC on here that has a short circuit between pins 1, 2, 3, 4, 5, 6 and 9. 1, 2, 3, 4, 5, 6, 6 and 9. So what does this do? This is a what the fuck is this? MM74HCU. Maybe I'll look up what that does tomorrow and see if that's got anything to do with our problems. It's 3:30 in the morning. What is that? What is that that's got a short circuit on it? It's strange because it's got a short circuit between 1 and 3, which is unusual. That is a 1AM F33E or TL431AC. Could be either of those. No, look, according to the traces on the board, it's meant to have a short circuit between 1 and 3. The traces connect 1 and 3 together on this. Okay. I thought I'd found something then. Okay, we're going to call it a night for this evening. I'm very, very sorry that we didn't get to see this up and running. I really thought that this was going to be a very simple repair of putting new drivers in, new resistors and new FETs, and she would work. But it doesn't always work out how you want it to. It doesn't always work out how you want it to. So tomorrow, what we're going to do tomorrow, the plan is to speak to my good friend Gordon at the Amp Doctor UK, who is the certified repair technician for JL Audio in the UK. He has all the schematics, he has access to all the schematics for these things, so he will be able to help me out here and send me a schematic, or send me parts of the schematic, because I don't know if he's allowed to send it all. He's not allowed to actually share any of that information with me, but cheeky, he's a very nice guy and he's incredibly helpful, even though I'm technically his competition, sort of, but it doesn't work like that in the UK. Everyone's friends. So he will probably help me out by advising me what those chips are meant to be. I know that they are correct, but he will confirm what they're meant to be, and I will explain this situation to him, and I'm sure that he will come forward with an answer, because he's very fucking experienced, like literally very, very experienced. He's been doing this for like 30 years plus, at least, maybe 40 years. So yeah, he will have an answer. I, who have been doing this for 1 year, am bedazzled. I am bamboozled. I am bamboozled. The guy who's been doing this for 1 year. I don't know why when we apply the driver chip, the waves from the smaller drivers from the generation circuits go bad. Doesn't make any sense to me at all. So, thank you very, very much indeed, you guys, for tuning in, keeping me company, and keeping me driving forward with this repair. 75 watching, wow, pretty decent, nice. I will see you in the next live stream. Probably gonna be, when is it? Might be next week now. I think I'm gonna have a weekend off. I've been in the workshop far too much lately. It's kind of getting to my head a little bit. So yeah, I'll probably see you in the next week. Have a great Friday evening, you guys, and have a fucking great weekend as well. And I shall see you in the next live stream.